Kirk-a-man. All right, we are back with number 8. This is the second part of going over the Unit 1 study guide. So number 8 is asking what is the GCF of the 2 prime numbers, and hopefully you remember that GCF stands for greatest common factor, and that prime numbers only have 2 factors. Only have 2 factors, 1 and themselves. So we need to find if I have 2 prime numbers, like for example, 7 is prime and 2 is prime. If I have 2 prime numbers, what would their greatest common factor be? Well, if you remember when we did our prime factor trees, I would know that the only factors of 7 are 1 in itself, 1 and 7. The only factors of 2 is 1 and itself, and you would find that the only factors that they have in common is 1. So it doesn't matter what prime numbers you do, the GCF of any 2 prime numbers is always 1. All right, number 9 up here. So Tommy plotted the opposite of 6. Alicia plotted the opposite of 5. Which number is greater in value? And explain. Now, in this one, we're going to type out an answer here in a second, but I want you to understand when you have a problem that asks you to explain, you need to be super duper clear. You really need to explain, and you could even show an example so that people understand what you're thinking. Because if all you say is Tommy, because his is bigger, that doesn't actually explain anything, and it could be difficult for the person to understand where you're coming from. So hopefully you already know the following information. Okay, so hopefully you already know the following information. So the opposite of 6 is -6. The opposite of 5 is -5. We know that the larger the negative, the smaller the value, because it is farther left on the number line. And you could even choose to draw a number line here and prove your point. You could even show that this would be -5 and that the next number would have to be -6. And so therefore, because 0 is way over here to the right, it's -5 is closer to 0. So therefore, -5 is larger than -6. All right, for number 10, we are looking at times for the 200-meter dash. Remember, these are decimals. When we're comparing decimals, these are all positives. We're going to start looking at place values. So we're starting as far left as we can go, and our 10s are all the same. So the next thing we're going to look at is our 1s. And again, we want a fastest time, and a fast runner has a lower time because they're fast. So they're going to get that to that distance in a shorter amount of time. So I'm looking for a really small number. So I already know that Allison and Carmelita, they are not my fast runners here. Okay, so now we're going to look at the next place value, and we're going to compare that. So we've got 2, 1, 9, and 9. So again, we're looking just down here. 9 and 9 are the same. So Shanae and Brittany are still tied. And so the last one we're going to look at will be the 8 and the 5. And with that information, I can tell that Brittany is the fastest runner because she had the fastest time, which means less time. All right, on number 11, we're doing that thing where we're putting these rational numbers, rational negative numbers, in order from greatest to least. So again, you could draw your number line and divide it up into 8 equal pieces, 6 equal pieces, 5 equal pieces. You can try to turn these all to decimals by dividing. Remember, your numerator goes inside the house, and your denominator goes outside the house, okay? But I'm also going to show you here that because we have whole numbers, this is a little bit easier to put in order than the last one we did. Okay, so I drew a little number line here with 0 through -3, and what I can already tell you is that 2 of these numbers have a different negative whole number, a different integer than the other 2. So I already know where they go on the number line, at least approximately, okay? So -1 and 7/8, I know is going to go somewhere here on my number line, okay? -2 and 5/6 is going to go somewhere here on my number line. So the only 2 numbers that I really have to worry about are going to be -3.2 and -3 4/5. And so, luckily, 4/5 is a very friendly fraction, and so is 2/10. And I can know automatically that 1/5 is the same as 2/10, which means I know that negative 3.2 is really negative 3 1/5, or negative 3 4/5 is really negative 3.8. So with that information, I know that negative 3 4/5 is going to be farther away from 0 than negative 3.2, and now I have my answer. So if I'm going greatest to least, remember closer to 0 is greater with negatives, so negative 1.78 is first, then negative 2 5/6, then negative 3.2, and then negative 3 4/5. All right, for number 12, we're talking about X and Y. So the thing you need to know about X or Y is that they're just placeholders. They're just representing any number in the world. So you can put any number in its place, okay? So if you wanted to, you could say that Y was negative 3 and that X was positive 3. You could say it was 12 and negative 12. You could say it was 7 and negative 7. It doesn't matter. They are any number, okay? So the idea is, and I kind of drew a picture here. So this is my number line. Here is 0. I have some number, which is Y. We're going to say it's negative 3. And then on the other side, the same distance from 0, I have its opposite, which we're going to say is X, which is 3. The distance between my numbers and 0 is the absolute value of that number, or in this case, that letter. So the distance between Y and 0 is Y. It's the absolute value of Y, the positive version, right? If it was 3, the distance would be, or if it was negative 3, the distance would be positive 3. The distance between X and 0 is going to, again, be the absolute value of X, the distance from 0 on the number line, which, again, in this case, is going to be a positive number. So it's the absolute value of X. And so the distance between X and Y is just going to be when I add the two numbers together. So it's going to be the absolute value of Y plus the absolute value of X. Or if I was doing this with numbers, the absolute value of negative 3 plus the absolute value of positive 3, which would be 6. So when you're explaining this, just use numbers to show as an example. You just pick numbers to represent them and then explain your thinking. So this right here is our answer. Okay. Same thing over here on 13. We have another set of X and Y. In this case, if X and Y are integers and X is less than Y, how do you know the opposite of X and how do the opposite of X and the opposite of Y compare? So again, pick some numbers. Any number that is less than another number. So I did negative 4. Oops, I did that backwards. There we go. Even teachers make mistakes. So any number that is less than another number. So I did negative 5 and negative 4. So we know that negative 5 is less than negative 4. Their opposites are going to change signs. So they're going to change their value. Okay. So if this is less than this, then I know that 5 is going to be greater than 4. So again, use the letters. If X is less than Y, then we know their opposites is going to be negative X is going to be greater than negative Y. You can even use a second set of numbers as an example. So let's do 3 is less than 4. The opposites, negative 3, is going to be greater than 4. So you could explain that I know because of opposites that the opposites of X and Y are going to be greater, right? Negative X is going to be greater than negative Y, and show examples to explain. All right, down here we have some more negative decimals, and we're going to compare them. So we've got daily temperatures on a 4-day period in Milwaukee. On which day or days was the temperature lower than negative 2.2? So I want something smaller than negative 2.2. And again, when we're in negative land, a smaller negative means a larger number, right? The value, the absolute value of that number is larger. So if I get rid of the negatives, I'm actually looking for a larger number. So the only one up here that is lower than negative 2.2 is negative 2.3, because again, it is farther to the left on the number line. All right, we're almost done. Okay, here we've got LCM of 3, 4, and 5. So I'm going to pause and do that real quick. Whew. Okay, so least common multiple. When I count my multiples, I skip count. Okay, so I skip counted by 3s, I skip counted by 4s, and I skip counted by 5s. When you have 3 numbers, this is the easier way. You could still do your prime factorization, but it does get a little tricky. Okay, so I have 3 numbers, and I'm looking for the number they have in common. So it was kind of tough. 3 and 4 had lots of numbers in common, but 5 did not. So we ended up getting 60. So our answer is 60 for my LCM. And then down here, it says a rational number is any number that can be written in the form a over b, where a and b are both integers and b is not equal to 0. Why is every integer a rational number? Well, every integer is a rational number because if you remember from the very beginning of the first video, integers are positive and negative whole numbers, like 2 and negative 2 and 10 and negative 10. And whole numbers can be written in AB format as a fraction. So any whole number can be written as a fraction by placing it over 1. And so even my negative numbers can be written as a fraction by making their negative number over 1. So therefore, every integer is a rational number because they can all be written over 1. All right, hopefully reviewing this unit study guide helped refresh your memory on a couple things. Please see me if you have any questions, and good luck on your test. Bye.